This is Mr. Beck does your homework. This is AP Physics, homework 5.3, question 13. It says, planet Zero has a mass of so many kilograms and a radius of so many meters. The space probe is launched vertically from the surface of Zero with an initial speed of 5 kilometers per second. What is the speed of the probe when it is this far, so many meters, from Zero's center? The gravitational constant is so many kilograms. Answer in units of kilometers per second. So let's worry about kilometers a little bit here. So what we have is a conservation of energy problem. We have a planet, we have the rocket probe that's launched, it has some initial potential energy here, and it has some kinetic energy here, because I'm launching it at a certain speed. When it gets up to its new height, it's going to have some new potential energy, and it's going to have some new kinetic energy. And I have enough information to solve for this initial potential energy, this initial kinetic energy, this final potential energy, and then I can figure out what the new kinetic energy is so that I could figure out the velocity. So I have my initial potential energy plus my initial kinetic energy is going to equal, because energy is conserved, my new potential energy and my new kinetic energy. So my initial potential energy is negative g, the mass of the planet and the mass of the object, divided by the radius of the planet, plus 1/2 the mass of the probe times the velocity of the probe squared. And that's going to equal the same gravitational constant times the mass of the planet times the mass of the probe divided by the new height, so I'll call that R2, and also the kinetic energy, which is 1/2 the mass of the probe times the velocity of the probe squared. That's the new velocity of the probe. So really, this should be R1, this should be V1, this should be R2, and this should be V2. What you'll notice is that all four of these terms contain a mass of the probe, the mass of the probe, the mass of the probe, the mass of the probe. So really, you don't care about the mass of the probe, and it doesn't even tell you the mass of the probe. So you are lucky, because this one goes away, this one goes away, this one goes away, and this one goes away. So what we're left with is all numbers that you know. So you know g, you know m, you know r, you know 1/2, you know this initial velocity. Then you can solve for these and bring this one over. Just be careful that this is a negative, this is a negative. You also have this initial speed is 5 kilometers per second, or whatever your number is. So this velocity is going to have to be in meters per second so that it will all work out. Once you find a final velocity in meters per second, you're going to have to put it back in kilometers per second. But this is your conservation of energy for this problem.